Hello everyone, I'm Alex Mustang and this is a tutorial of a program I wrote to control the Mekanism Fission Reactor. So basically the setup I built here is a 5 by 5 by 5 fission reactor with 10 millibuckets on per tick max burn rate. With a boil efficiency of 1, circuit to reclaim the water, and the industrial turbine. The induction matrix, it's kind of irrelevant for the experiment. It's just to dump the energy. I could have used creativity, but whatever. So the program, it can be run on ComputerCraft. To be more specific, ComputerCraft Tweaked, CC Tweaked, and it's connected with the modem like here, and with cables to the turbine and the fission reactor. Note that you should have just one reactor and one turbine. Then you go to the computer. Note that the monitor is optional, and I recommend 5 by 3. Also the disk is optional, but we'll see in a second. So you go to the computer and you download this file right here, this code. I put it in the description of the video. And you name it startup.lua. You don't have to write startup necessarily. You can name it whatever you want. In this way, you just keep the reactor safe. Like if you join a world, the computer will reboot, and naming whatever file in the computer in the root or this directory, basically when there's just this, name it startup.lua, and the computer will execute it. Obviously you have to be in a chunk thing loaded with the computer, and you can see here I did it all in just one chunk. This is the optional not the optional, the optimal setup. After you've done this, you can do one or two things, whatever you like, and you go to edit startup.lua, and you can change two things here. Basically, this one controls where the config file will be stored, and this one where the log will be stored. What are these? If you do like this, it's the same directory where it's saved the startup file, or just the root directory. So you go like this, and you save it. Also, the log one, it's just when the program shuts down. The program just stops, but not in the case of error. This one, it's going to save the file only and only when it's programmed to do so. Like he encounters an exception. For example, in this program, I have the feature of nuclear waste threshold, basically this one. By default, it's 80%, but we'll see it in a minute. Oh, the 80% it's not configurable right now. But we exit, and then you have to reboot the computer. It reboots a second time because the first one, it makes the file, then it reboots, it checks the file, and he then goes on the second one. As you can see here, the controls are pretty basic. You can have the deactivation one, deactivation input or a Scrum one. What they do? You see here the status of the minimum and maximum. We'll see it in a minute. We have the reactor stats and the turbine ones. They're the basic ones, basic stuff that you can even see from the stats of Mekanism. But something that you can see is the heater of fuel. It's a feature I implemented, and it basically is a timer for the fuel going out. If, for example, I cut the fuel supply, you see the fuel going down, and after some time it goes down along with the burn rate. It's controlled by the burn rate of the reactor. Now I will explain how it works specifically. So the deactivation, it's just this. So as long as you keep a redstone input, whatever the signal, on this side, the reactor will remain shut down. But as you can see, it updates because you don't stop the program. If you toggle the input, it just goes to normal. The Scrum one, instead, it's an emergency shutdown. As you can see now, it said saving in log.txt, saved successfully and terminated. Now, if you do this, ls, it's a command that says what is in that directory. You can see the startup.lua and then these files. Okay, so there's nothing in disk. Let's see first the program, the files, what they say. So if we go to config, we see this. What is this? We have first this one. How you say? This is this controls the reboot one. What I mean by that? When the program it's launched for the first time, so it creates a new file, a new config file, this number is set to 1. So when the computer reboots and reads the file and sees 1, it turns it to a 0 and reboots. And this one, it's just to not make a loop, an infinite loop, and I suggest you to leave it like that. If you have to, I don't know, make it to default, the config, maybe someone gain access to this file and made something. You just turn this the first number to 1, and the program takes care. Then this number, it goes from 0 to 1, but I suggest you to leave it always above 1, above 0. Sorry. It's a maximum burn rate. So the program first reads the maximum burn rate of the reactor. Okay, it's 10 in this case. It goes here and it multiplies by 1. So 10 times 1, it's always 10. If I change this to 0.5, for example, it goes like this. Sorry, I was interrupted. So, like I said before, each change it changes the maximum burn rate of the reactor, but it is how you say it, an override. We make it like it was before, and this is the minimum and the maximum I said earlier, like the 20-80%. So it goes like this. if I cut the energy supply to the index matrix, the induction matrix, we have the buffer, okay, the turbine buffer. What the program makes is this. So it checks the percentage of energy in the buffer, and if it goes above 80%, it shuts down the reactor. And if you pull the lever, it's not like the opposite, it's just shut down until the energy goes below 20%. So it's not like it goes to 80 and you see the reactor flickering. It's above 80%, then it goes down the energy because it's consumed. And if you go below 20%, then it's again started up the reactor, and it goes like this in a cycle. You can of course change the values, and you can make like this the minimum 0% and this one 100. Also these two numbers goes go by from 0 to 1. You can change it whatever you like. These two words refer to the size of the inputs. So relative to the face of the computer, the first one, it's for the activation. In this case, it's left, and this is for scram. Okay, so if I just reverse the two and I reboot, you can see that if I go like this, it takes it's like opposite. I did the opposite of the inputs. So this one is now for the activation of the reactor, and this one is for scram. Okay, it's really simple. And we revert back to what it was. Okay, now these two are pretty technical. So this one, it's for the delay of seconds for the heat of the fuel. What it means is that every 5 seconds it checks the fuel, the burn rate. Sorry, the burn rate it's velocity. Okay, let's imagine as velocity because it is. While this number here, it's how many memory cells this system for the time left uses. We have 10 in this case. So every 5 seconds it changes one cell to the value it saw. Then it takes all the values different from zeros. It counts them, like we have 2 numbers and the rest is 0. Okay, 2 are numbers and 8 are still numbers but 0. They're 2. So it takes those numbers and it makes an average. That average it is the average velocity. Then it uses that velocity, and it uses the, you could say, the volume, or at least how much fuel is left. The number, it takes the number, and it makes a calculation, and it prints a number that is the seconds left. Or at least it calculates the seconds. Don't see the real seconds. It then converts them into hours, minutes, and seconds, as you can see in the parentheses. Now, the config file is done, and the last thing to see is, at least the second last thing to see is the log. Now, it may seem complicated, but it really isn't. So we see in the first line the log, and it says the name of the day of the week, the month, and the number of the day of the month. Then we see the what hour is it, what time is it, specific to second, and the year. Then this Tesla means time elapsed since last execution. So the program, what it means that is that the program from when it started up to when it encountered this exception. This is the exception you have to see that number, and then it makes a calculation of the time that elapsed, and it prints it like you saw there. Then we see the main reactor stats, like the last temperature recorded, the bar rate, the heating rate, the coolant, that what it was and how much it was left, the fuel, what fuel it was and how much it was left, and the waste, what it was and how much it was left. It may be useful, like it encountered the exception of the maximum waste, 80%, like I said before, and maybe you have an automatic system to deal with this waste, and then you come back and you see the program like crashed. It's just shut down, and you see the reactor not making any energy. Then you come to the log and you see, oh, it was 80%, so it shut down. And the same goes with the turbine. As you can as you know, the buffer, if it goes to 100%, the mechanism turbine doesn't turn any steam to water back, so the reactor doesn't have any water, so it doesn't shut down for the full buffer, but it does shut down for the critical level of coolant. A note to make here for any use of this program, maybe I had to say it at the beginning, is that it's also said here, you may not use this program for a sodium cooled reactor, because it doesn't check the boiler, and it may be unpredictable how it works, because the boiler is similar to the turbine in terms of conversion, okay, of the coolant. So it's not that it doesn't work, it's just that it's unpredictable, and I don't think you want a meltdown, especially because the sodium cooled reactors are very large, and they result in a bigger meltdown than these ones. The last note I have to make is that you can change the directory like this. So now they're not stored in the... They're not stored here. We can also delete them. So as you can see, there's nothing. Now, if I turn this computer on, it goes like that. It what? Oh, it's not. Whatever. You can see the it working. You can't really see the flop disk. But what happens is that if I scram this reactor and I go like this, there's nothing. But if I go like this, now you can see both files here. You can change the directory like how you want, like whatever you want. And it should work unless the directory doesn't exist. It doesn't create the directory. So it maybe won't work. It's the same. Okay. So this is all I had to do to explain. And maybe future versions may integrate the boiler. I don't know. these are the main features for now, and thanks for watching. Bye!